Hey Kaylee, this is Miss Tracy. So this is lesson 76. She got the first one right, I think, because that's the one we did in school, in class. So let's look at the other two that you did not get. So the first of the two you haven't answered. It says to find three consecutive integers. So the main thing that you have got to do to find consecutive integers is first you've got to set up your formula. And for consecutive integers, it's always going to be the same thing. You're going to have n, you're going to have n plus 1, and n plus 2. Now this says find three consecutive integers. So this is the first one, second one, third one. That's all you have to do to set up your equation for your three consecutive integers. They're one right after the other, so we add one each time. We add one to the first one to get the second one. We add one to the second one to get the third one. All right, just like on the number line. Now we just have to look at the rest of the word problem to see what it says. Such that is your indicator that what follows is going to be the equation. Okay, so three consecutive integers such that the sum of the first and third is 142. So the sum of the first, here's the first, be the sum of the first and the sum of the third. So the sum of means to add them together. So the first one plus the third one, and the third one is n plus 2. And that's going to equal, because it is 142, so it's going to equal 142. So n plus n, we know there's a 1 in front of those. N plus n, that's going to be 2n plus 2 is equal to 142. So we subtract 2 from both sides, just like normal, just like a regular one. Equation, we use the subtraction property of equality, and now we say 2n is equal to 140. Now we just divide both sides by 2, and we find that n is equal to 70. So now that we know what n is, we can substitute that in for all of these equations, right? N is equal to 70. N plus 1, 70 plus 1 is 71. And 70 plus 2 is 72. Those are our three consecutive integers. You see, it's not that hard. It's just about understanding the process. Step 1, create the integer equations. Step 2, write out the equation. And step 3, solve the equation. Then step 4 is to solve the integer equations. Those are your 4 steps. Create your integer equations. This is first. This is second. This is third. And then this part right here is fourth. This is the last part. Then this is the part that you type in to the blanks. 70, 71, 72. 70, 71, 72. Okay? All right, Kaylee. Here is, let's do the hard one first here. So we have y plus 2 over 3 minus 5 over 2 equals 2y minus 4 over 8. So we're looking at a problem with fractions. We're going to do the same thing to this problem that we have always done when we have a problem with fractions, and that is find a common denominator. It is the same process for every fractional math problem that we have. We always want to find the common denominator. So that's step 1, common denominator. Always, always, always. Otherwise, we can't solve the problem. We can't move forward unless we can find something in common between these 3 terms. And that's going to be the denominator. So we look at these and we say to ourselves, the factors here are 2, 2, and 2. So that includes this one. So now we need to include the 3 because it's a factor, it's a prime factor of its own. So because this 2 is included here, we can just say 3 times 8. And that includes all the factors of all the denominators. So our common denominator in this case is going to be 24. Right? Because we can't multiply 8 times anything and get 12. So it has to be 24. So now we're just going to multiply this entire fraction by the number that makes this denominator 24. Just like we would for any other fractional problem, we treat it the same way. So what we do, we know we need to multiply by 8. We just do that. We say 8 times y plus 2 over 24 minus. We know that we need to multiply here by 12. 12 times 5 is 60. So 60 over 24. And here we know we need to multiply by 3. So we say 3 times 2y minus 4. Right now, we're just fleshing out what we have to do. You don't have to follow it all the way through because there's another step. Because, excuse me, something I ate. Because this is an equation, once we have all these common denominators, we know that the golden rule of equations is that whatever we do to one side, we have to do to the other. So if everything here is being divided by 24, we can multiply everything by 24 to cancel out the denominator. So if I multiply this by 24, and I multiply this by 24, and I multiply this by 24, this cancels, and this cancels. So I'm left with 8 times y plus 2 minus 60 equals 3 times 2y minus 4. All right? That is why we do the common denominator. We make these things have some commonality between them by finding a common denominator, and then we can get rid of it. That's the whole point of finding the common denominator. So we find a common denominator, we multiply as needed, then we eliminate the common denominator. Right? That's step 3. And this is what we have left. Now we're on step 4. Now we solve. That's all we're going to, those are the 4 steps. Find the common denominator just like you would for any fractional problem. Common denominator, multiply to get to the common denominator. But now that it's an equation, we can eliminate the common denominator and just move it on to whole numbers. And that's because we did that step. It's almost like an invisible step of multiplying everything. You don't have to show. You can go straight from here to here if you wanted to. All right, so now we're going to say 8 times y is 8y. You know how to do this part. This is the easy part, right? We've done this a bajillion times now. So we'll subtract 6y from both sides. If I could put it in the right spot, that would be great. And the reason I'm subtracting 6y is because 8y is bigger. I combine these two together and I get negative 44. So I'm going to add 44 to both sides, right? Because these two together is negative 44. So I'm going to add 44 to both sides and I get that 2y is equal, because this cancels. This becomes 2y. This would cancel. That would be 32. So y is equal to 16, which is what we have right here. That's our answer, 16. Okay? So you see how to do that now. Common denominator, then get rid of the common denominator and we can just erase it and write the whole numbers. But we have to make sure they're relative to one another before we can do that. Technically what we're doing is, like I said, we're finding the common denominator, and then we're multiplying each term by the common denominator so that we can eliminate it. We're doing the inverse operation to it so that we can make it easier to solve. But we can only do that when it's an equation, because if it's just an expression, if there's no equal sign, then we can't do the same thing to both sides to get rid of it. It just doesn't work that way. So that's only something you can do when you have an equation, is to get rid of the common denominator like that. All right, so now that you know how to do that one, I'm going to let you do the easy one on your own. Let's see what the other one was. All right, scientific notation. One of the things that I saw in your answers is that you were using an asterisk to try to type it in. It's not an asterisk. So in one of your modules, I showed you how to do the scientific notation. Click here, go to basic math. There's your X. Okay, that's in the basic math one. First, let's solve this before we try to type it in. Okay, so we have 0.07 times 10 squared, 800,000, and then 10,000. And oh my goodness, we have 1, 2, 3, 4, 5, 6 fours. 0.1, 2, 3, 4, 5, 6 fours and a 4, or zeros and a 4. We need to put this in scientific notation because it's not. Scientific notation is a ones place times 10 with an exponent. There's always a ones place right here. We try not to have any decimals behind it, but sometimes we do. So we want to look for the ones place. So here we need to make a 1. So this is going to go to the right. 1, 2. So when it goes to the right, I hate it when it does that. 1, 2. When it goes to the right, it is subtracting. When it goes to the left, it's adding. Okay? To the right, it's minus. To the left, it's plus. It's the opposite of the number line. If you remember it's the opposite of the number line, then you will get it right. So this is going to be 7 times 10, because 2 minus 2 is 0, right? And that's to the 0. We leave it to the 0. We write that to the 0. This one, we have moving it 1, 2, 3, 4, 5 spaces. So it's going to be 8 times 10 to the 5. 7 times 8 is 56. 56 times 10. 0 plus 5 is 5. That's the top. Now we do the bottom. 1, 2, 3, 4. 1 times 10 to the 4. And then this is going to be 4 times 10. We just have to figure out the spaces, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So that's negative 7 because we went this way. 1 times 4 is 4. 4 minus 7 is negative 3. Now what we need to do is say 56 divided by 4. And that's going to be 14, I believe. Yes. So 14 times 10. When we bring this up to the top, it changes the sign of the exponent. So it's going to be 8, right? But we have 2 digits here. We only want 1. So we're going to move the decimal to the left, which means we're going to add. So it's going to be 1.4 times 10 to the 9. So what you want to do is you want to come up here and say 1.4 times 10, and then go back to the algebra keyboard, get the exponent, and type 9 right here. Check it. And that's correct. Okay? That's how we do that. Let's go to the next one. Scientific notation is not the funnest stuff in the world, but it's not the hardest stuff either. It's pretty darn straightforward. It's the same formula each time you do it. It does not change. I'm going to do one more of these for you, and I'll let you do the rest on your own. The first thing you always do, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the number 4. And then this is 50,000. The first thing you always do, step 1, simplify. Right? Simplify your scientific notation. So we're going to put this back into the 1 times 10 to the exponent format. So the top is going to be 4 times 10. And we got to figure out what that is. So remember, this way is minus. It's opposite. And then this way is plus. So to the right is minus, to the left is plus because it's opposite the number sign, the number line. So this is going to be minus 1, 2. So minus 2. So that's going to be minus 11. This is going to be 5 times 10 to the something. To the left is plus, so it's plus 1. So to the 17. 5 times 10 to the 17. Do the same thing here. We know it's going to be a 4 times 10 to the something. 1, 2, 3, 4, 5, 6. And it's to this way, so it's minus 6, minus 6. And this one's going to be 5 times 10 to the something. 1, 2, 3, 4. All right, and it's this way, so it's positive. So it's 4, positive 4. Now we multiply. 4 times 5 is 20 times 10. We add the exponents together. Negative 11, positive 17. That's going to be a positive 6. Right? 4 times 5, that's 20 times 10 to the something. Negative 6 and positive 4, we add those together. That's going to be negative 2. 20 over 20, that's 1. 20 divided by 20 is 1 times 10. Now, we bring this up, so that's going to be a plus 2 because it changes the sign. When an exponent comes from the numerator to the denominator, remember, it changes the sign. So 6 plus 2 is 8. So the answer is going to be 1. Go to our basic math, get the x, type in our 10, go back to the algebra, get the exponent, and that's 8. Check it, and it's correct. See how easy that is? You can do this. All right. Just remember when you type in your formula or when you type in your scientific notation to type the first number, to get the basic math x, 3, type the 10, 4, get the algebra exponent. Do not put any spaces between these. The spaces automatically appear when you click on that exponent button. It's going to automatically set it up. So don't put any spaces between them. Type the first number, get the x from the basic math keyboard, type the number 10, and then get the exponent from the algebra keyboard. And all of that is right here at your fingertips, right? Basic math and algebra. Those are the two you're going to use. Basic math is that. Algebra is that. That's how you get your special characters. We've already done this before, so you should be comfortable with that. All right, so these two that are remaining, number 4 and number 5, I expect you to be able to handle on your own now that we've been through 2 of them. Just use the same process. We simplify, and then you, after you simplify, you're going to multiply the whole number, okay? You multiply this number and this number. We always treat times, 10, the whatever, this is a variable. Okay, the variable is this. You've got to break it down in your head like that. This is the whole number, this is the variable. So after we multiply the whole number and get that answer, then we take our variable, because they're the same, times 10, it's the same variable. We look at the exponent and we just add the exponents together. That's what we do, okay? Then we do the same thing to the bottom. We do the whole number times the whole number, and then we take our exponent from our variable, which these are the variables, and then we add the exponents together. Multiply the whole numbers. Step 3, add the exponents. Okay, do the same, repeat. Number 4 is to repeat for the denominator. Then you treat it just like a regular fraction. Again, these are the whole numbers, so you look at them, and then you look at this over here, right? So number 5, divide whole numbers. And then number 6, move the exponent for the variable to the top, change signs. All right, then you add them together. If this had been a positive, you would have subtracted it, but it was a negative, so we added. We just swing it up and we just treat it like a variable. That's all it is. And then when you're done, you get your answer. You type it in. And then this is how you type it in. All right. If you have any other questions about those lessons, please let me know. That should cover the basics on how to do those. It's very important that you think of times 10 to the 11 or times 10 to the 17, that you think of these as variables. They don't have any real value. You know, they really don't. The value is in the exponent. That's the only thing we're calculating. We're not worried about the times 10 part of it. That's just the variable. All right, I will see you in class very, very soon, and happy Valentine's Day.